All right. So we're gonna record this real quick. Let's go to Google Classroom. Let's watch some of these videos. All right, let's start all the way over, just in case.
No, mine's not uploaded yet. Mine's not uploaded.
All right, we'll come back. We'll come back. All right, we got first one. First one. Here we go.
Welcome to the world's shortest filter machine.
The shortest one. That was pretty cool. All right, did we have three simple machines there? Incline plane.
Wheel and axle.
Wheel and axle.
And then a lever at the end.
Lever at the end. Actually, you had a wedge back there too. So technically, there's four. Pretty easy. Nice, short and sweet. All right, let's see what else we got. Ooh, another one. Which video is it?
It's both of them. It's for different views.
Oh, a multi-view. That's pretty cool. All right, we're gonna watch both of them.
How do I do this?
All right. View number one.
I turned ours in.
View number two. Oh, side view. Pretty awesome. All right. Did we have 3 simple machines there? Incline plane, wheel and axle, pulley. Definitely, at least 3. Perfect. Isaac said he had his. Let's go back to Isaac. Let me refresh my page. There it is. That. Oh, they're processing it. We'll come back. We'll come back. All right, Cole. Let's see. I can't open his. All right, let's see. Who else submitted it? Kyle. There we go. Next one. Okay. So, were there 3 simple machines in this one? Incline plane, lever at the beginning. Saw a car at the end, so that's a wheel and axle. And it's promoting recycling.
Hey, great message.
Great message. All right, let's see what else we got. Sarah. Okay. Check this out. Here we go. All right, so we had we had an incline plane, little wedge there. Had a pulley system. Pretty good. All right. It was.
I just turned.
There's water poured in the cup. Oh.
Yeah, water pouring in the cup.
All right. Did I miss anybody?
Isaac.
Let's go back to Isaac. No, we gotta watch Isaac. Wait, did we watch Lexus?
No, it's not on mine. It's on mine. It's on so.
What's this then?
It's not loading.
Mine's not loaded either.
We're gonna download, see if that helps out.
Oh, it's the
Here we go. Okay. So we had incline plane, we had wheel and axle. Technically, these books act as a wedge. Sharpening a pencil.
That's pretty dope.
Easy enough.
Loaded orange yet?
I just watched it. All right, let's do the same thing. Should work. Should work. Let's download it. 3, 2, 1. Let's go.
Maybe do mine.
Whoa, that's pretty dope, you guys.
Okay, okay. Sophie and Nick. All right, last one. Maybe let's refresh this. There we go. 2 views.
Yeah. Or let's do fold it sideways.
All right, everybody turn their heads. Oh, no, don't turn your
Oh,
heads.
no. It's gonna turn sideways with the watch.
Just pretend it worked.
Whoa. That was pretty cool. That was pretty cool.
All right. Same video. Is it the same thing?
This is a nice transition.
That's a pretty dope machine.
That's a nice transition.
That is a nice machine.
All right. There are our Rube Goldberg experiments. Question.
Oh, I was saying what the simple machines we had.
Oh,
We had a couple.
what
We had
all?
a pulley, a lever, incline plane. We had a wedge too. I think that's it.
What did that even
Yeah, we
do?
had it.
What was that supposed to do?
All right. So there's all our Rube Goldberg experiments.
Hey, Mr. Bowers, you should have made one and just show how much cooler yours would have been compared to all ours.
Maybe.
Ours were,
Maybe. All right. So with that being done, second half of class, what I want to do is I want to introduce what heat is. Then we'll be good to go. Sound good? So I'm going to turn on the backlight just so I can see you guys a little bit. So backlight's coming on. 3, 2, 1.
are you sure?
Oh, I didn't turn it on. I like it clicked. Did you hear it click?
Yeah, I hear you.
That was weird. Okay.
You got the second time now. Good job.
All right. So. Where's my little clicker go?
Mr. Bowers, can we draw a smiley face up there before we start?
I don't know where my clicker guy went. All right. So. Talk about heat. What do we know about heat?
Wait, no.
Can you say that again?
Heat is something hot.
Heat conducts electricity.
We also do metal.
Heat comes from rays.
Heat comes from rays.
Yeah, like sun, the sun.
So heat comes from sun.
Yeah, from sun. Heat comes from the water. Well, sometimes.
Is it like the movement of
Particles,
right?
the sun goes water.
Movement of particles. What else about heat? Cole, yeah, what were you saying about heat?
What did you say, buddy?
You were talking.
Oh,
I couldn't hear you.
it's like different materials have different transfer rates.
Different different
Like
heat.
if you pick up a piece of metal, it will feel colder than if you pick up a piece of plastic.
Ooh, so different.
I don't
Different.
know what that's called.
transfer of energy.
I
Okay.
think it's literally just transporting.
Okay. What else? Which is pretty much that. What else? What do we know about heat?
Warm.
Heat's warm?
Electricity.
Hot.
That's what I said. You copied my answer. Heat
Is
conducts electricity.
heat cold?
Yes.
No, wait.
Not
So we said heat is warm and heat is cold.
Isn't technically
How
the
could heat be
cold
cold?
heat?
Okay. What else do we think we know? Anything else? So, got a question for you guys.
Yeah, what's up? Wait a minute, isn't technically, what's it called? The one kind of ice. Yeah, dry ice.
Little question.
We're getting.
Oh, I can't hold that in.
Make a big domino rally.
This man wants to share us.
All right. I want you guys to feel these blocks. I want you guys to feel these blocks.
I got you gotta promise
All right. So, question for you. Are you guys, have everybody been able to feel the difference? Okay, question for you. Which one feels colder? Probably the metal one. It probably sounds like that one, right? Feels colder. What if I told you they're the same temperature? Would you believe me?
Yes.
Why?
Yo, what? It's because it's like.
Wait, hold on.
I don't know the reason why, but it's because the metal can transfer like the heat quicker than the piece of wood or whatever the other piece is.
They're just
So-
that's why.
So they have the same temperature?
Yeah.
What temperature do you think they have? Room temperature. I heard it. Room temperature. Both of these are at room temperature. Now, one feels cold, the other feels warm. That's pretty crazy. They're the same temperature. Right? Okay. So, if we know what temperature is, I can't believe I don't know where my clicker is. That's pretty sad. Oh, you know what I should use?
Ooh, we should use a pen.
I haven't got this out for a long time. There it is.
I like that.
Whoa! Oh my
See
god.
See if this
I
works.
wonder if this thing is bouncing.
Okay, my laser works.
Whoa, put a laser in my eye. Point the laser in my eye.
Oh, there we go.
Yay.
Nah, it's just gonna be easier doing this. Okay. So, guys, let's not. So, temperature. Temperature measures the kinetic energy of molecules. Okay, so if we're measuring the different kinetic energy, that means in a gas phase, energy is crazy. It's off the charts, right? Because it's going so fast. Where in an ice phase, it's more compact. All right, so there's little kinetic energy. All right, what are 3 units of temperature? What's one?
Fahrenheit.
Fahrenheit, 1. What's the second one?
Celsius.
Celsius, 2. What's the third one?
Degrees. No.
Kelvin is the third one. Very good.
What is it?
What was
Kelvin.
the last one? Kelvin.
What's that?
Oh, yeah.
It's the SI unit for temperature.
I don't know what that means.
It's the scientific unit for temperature.
That's what they call it.
Yeah. Yeah. Okay. So we know what Celsius is. Celsius plus 273.15 is equal to Kelvin. Okay. So Kelvin is a pretty big number. It's a big number. Now, can Kelvin ever equal 0?
Yeah. But it has to be really, really cold.
We've never reached absolute 0 before. We've never reached 0. We've gotten close, but we've never reached 0, and that's crazy.
What? Here?
What?
What are you talking? I didn't hear that.
Why, was I talking softly?
I just
No.
My bad. I'll talk a little bit louder.
Okay.
Okay, so Kelvin is a pretty big number if it's 273 plus Celsius, but have we ever reached 0 Kelvin? And the answer is no. We've gotten close, but not 0.
How close did we get?
I think pretty close, actually, like 0 point some number. Like 0, but we've never
Pretty
been.
close. I mean, I think it can be done.
That's called absolute 0, okay?
I think we can do it.
Can we reach almost? Oh, here we go. Scientists have gotten within a 1,000th of a Kelvin. There's your answer, Isaac.
A 1,000.
We've gotten 1,000.
So you can.
All right. So heat is different than temperature. This is how heat is defined. All right. Heat is defined as the energy transferred between two things. So the movement of particles, this was temperature. Okay? Different transfer of energy, that is heat. There's difference. Okay? Heat is defined as the transfer of energy. So when you're touching the one that feels cold, how is heat being transferred? When you're touching the one that is cold, how is heat being transferred? Yeah. From your hand. So the heat is traveling from your hand into the block. That's pretty crazy. Right?
Yeah.
That's pretty crazy. Okay? And we already got that. So it goes from a higher temperature to a lower temperature. I think you guys already knew that, right? All right, higher temperature to lower temperature. Okay? So, in this first example, when you're holding the pie, it's a frozen pie. So how's heat being transferred? Through your hand to the pie. However, when you're holding a hot pie, how is heat being transferred? So what?
It's traveling over
The heat's traveling from the
It's
pie to your
traveling into
hand.
the oven mitt.
It's traveling from the pie to your hand because that's the hotter object. Does that kind of make sense? Okay.
It's harder.
Now, to finish off here, we're going to be talking about 3 different. Oh. Yeah, I want to talk about conductors. Okay. We got two things we're going to go over. Okay. Conductors. All right. The one that feels cold, that's a conductor. All right. It transfers heat pretty easily. All right. The other one's called an insulator. Okay. Insulators is the complete opposite. It does not transfer heat very effectively, which is wood, rubber, air, fabrics, body fat, styrofoam. They do not transfer heat that well. Fair enough? All right, now the last thing. There are 3 ways to transfer heat. 3 ways. Anybody want to take a shot at one of them?
A hair dryer.
Okay, so heat traveling through a medium, like a liquid.
Yeah.
Very good. That's one.
You know, like coils, hot coils that heat up and then like air like conduction. Like
That's convection.
Yeah.
That's the same thing as a hair dryer.
Yeah.
All right, so conduction. Transfer of heat by direct contact. Ha! Don't touch the top of that. Too hot. Direct contact, right? Direct contact. Now, what's crazy is, have you guys ever heard of graphene before?
Yeah.
Awesome stuff.
Now a master of the material universe. Melting with almost half of the rates, Max Prinsky is demonstrating the world's most wonderful material.
Without pressure, it just melts through the ice.
He has just taken his own body heat and used it to carve through ice like it was butter.
This is my absolute favourite clip because it contains my personal favourite material, graphene.
And what is this wonder stuff?
We're used to seeing carbon in the form of graphite in things like pencils. Now, graphene is one single atom-thick layer of exactly the same substance.
What Max has got here is something called pyrolytic graphite. And this is where you take single layers of graphene and then you stack these layers on top of each other. So you get something that's about a quarter of an inch thick. What this material is really good at is conducting heat.
So, if heat is essentially atoms vibrating quickly, then how is the heat getting from his hand to the ice cube?
If we could look in and see the atoms in this material, then the atoms that were next to Max's hand would be vibrating very quickly. And because of this highly ordered structure, one atom would then bump into the next atom and would transfer these vibrations straight down the material really quickly, transferring this energy to the ice cube.
Okay, Suchana, let's see how hot your fingers are.
Now, all I'm going to do, I'm not even... This is just sliding through like a knife through butter. Oh, wow. Oh, this is so cool. Sorry, I'm geeking out in that. Take this away from me. I really want it.
That's pretty crazy. Pretty crazy stuff right there. So that is called.
Writing's not that easy. What's grammarly to help? This is it.
All right. So that is conduction. How do we feel on conduction? Direct contact, touch. All right. Convection is an example Will gave us. All right. Heat traveling through air. Heat traveling through water. There's heat traveling through a medium, like a liquid or gas. Okay. That's convection. All right. Now we have convection in weather. Okay. So we have wind currents. This is how convection looks like. You got a cold front coming in. You got a hot front, or a warm front, they say. That's pretty cool stuff. Okay. Anybody interested in being a weather person?
No.
Meteorologist?
How's that? Do they get paid good?
Oh man.
How much money
They're always wrong now.
How much do they
Exactly.
pay?
So
Get paid for being wrong?
yeah, sounds good to me.
Sure, I'll do
All right. Last one. Last slide of the day. Radiation. Radiation. Okay. Transfer of heat by electromagnetic waves. Okay, now we're not talking about electromagnetic waves yet. We will get there. There's a lot of different kinds. For example, radio waves. Anybody listen to the radio today?
Yeah, of course.
You listen to electromagnetic waves. Did anybody use a microwave today? You used electromagnetic wave.
I used to love it.
I'm like is that cool?
Yo, it's really easy.
If you want.
Hey, what's up, guys?
That's Bryce.
That's me. I'm Bryce. What's up?
I miss your brown.
It's actually Mr. Bowman.
It's the heating up.
I just said that. I don't know.
I know, I'm just making sure everyone
Thank you,
hears
guys.
me.
I appreciate it. They found my mouse.
He found your mouse?
It was like a magic trick. Say what? Let's see if it works. Maybe it doesn't work.
What if somebody used it and just started clicking everything?
That could be. All right. So electromagnetic waves. We said radio. We said microwave. Ultraviolet. Where do we get ultraviolet light? The sun. Love the sun.
The sun's a pretty cool dude.
The sun creates radiation. What kind of radiation?
Mr. Ballard.
We know this.
Mr. Ballard.
Ultraviolet, but what kind of radiation? I know we know this. I know we know this. Fusion. The sun uses nuclear fusion. Wow. That's kind of like deja vu.
Whoa,
Holy
that
smokes.
just hit me. That just hit me.
All right. So that is radiation.
I didn't know.
All right.